Alright, today with our motion analysis lab, we're going to be creating a parabola with our dog Harry. And we're going to throw a tennis ball to him, and we're going to calculate the horizontal distance that he jumps to catch the ball. As we know from symmetrical parabolas. So, from what we know about symmetrical parabolas, the speed will decrease until max height, and then, once Harry reaches max height, his speed will increase. His acceleration doesn't change throughout the parabola. Furthermore, at max height, his y-component velocity is 0, and his time will be half the time it takes for him to complete the cycle of a parabola. Hey! Hey! Alright, first we need our supplies. I don't have my glasses on. Alright. Hold on. I'm a little flustered. Keep rolling. Alright, so with our food dye, we're going to use this to mark where Harry's back legs start and end. And with the tape measure, we're going to use that to measure the distance between the two dots of food dye, so we know what the distance is. Then, as Harry jumps, we're going to time the jump. That way we're able to find our x velocity, and we'll go from there. Alright, so as you can see, we filled the starting spot for his paws. Good. Hey! Get back here. Stay. Was that good?
It's good enough.
I got 0.38 seconds. Inside. From timing the experiment, we got a result of 0.38 seconds. It's pretty good hang time. Alright, now we're going to tape this. Measure this. Alright. So we're going to start here. Can you stomp on this so it stays? And so right here where Harry's paws started. Now, this says here about 1 meter, 1.2, 1.3, so about 1.32 meters. It's a horizontal distance of this parabola. So here we have our data table for our parabola. First off, we have our time, and the total time for completion was 0.38 seconds. The horizontal distance for this parabola was 1.32 meters. By using the distance over time, we were able to find a horizontal velocity of 3.47 meters per second. Next, we wanted to find our initial y velocity. We did so by locating the dog at max height. At max height, the final velocity would be 0. The acceleration would be negative 9.8 meters per second squared. This is because the dog would be going against gravity. Furthermore, our time would be 0.19 seconds. That is 1/2 of our original time, because at max height, it is only 1/2 of the parabola.
All right, so at time equals 0, the original velocity is 1.86, and we found that it slows down to 0 at the midpoint, 0.19 seconds, and then it speeds up to negative 1.86 meters per second. That's negative because to indicate direction. And then the acceleration at the start is negative 9.8, and it is that way until the midpoint, at which point it becomes 9.8 because the object, the dog, starts moving with gravity. And the speed, because the velocity and acceleration have different signs at the start, would be slowing down because they have the same sign, it's speeding up. And then at the midpoint, it's stopped because there's no vertical velocity, and then it speeds up until the end where it slows down. And the direction at the start would be stopped, then moving upward, then stopped, then moving downward, and then stopped again. So for motion formulas, we used one of the kinematics formulas and plugged in some values, and we got y equals 4.9t squared plus 1.86t, which is verified in our graphs. And then if you take the derivative of that, you can get the velocity formula, which is 9.8t plus 1.86, which is again verified in our graphs. And then the acceleration would be 9.8 meters per second squared. And that is also verified in our graphs.
So, our hypothesis was correct based on the basic observation that the dog Harry moved in a parabolic sort of motion. We were able to calculate the original acceleration, velocity, max height, and horizontal distance of his jump. And yeah. What exactly?
Stop! You have violated the law.
Thanks for watching. That was good.